But the fact this is genuinely coming from rolling a dice on a computer and doing it quickly makes me, I don't know, just slightly disturbed about reality. Let's call this A, B, and C. And I'm going to put a starting point just randomly on the paper. And all we're going to do is roll this lovely dice to decide which point to go towards. And we're going to, whatever point we choose, we're going to go halfway. So let's call A 1 or 2. If we get a 1 or a 2, we'll go halfway towards A. And this is going to be 3 or 4. And C can be 5 or 6. If I could get a computer to roll the dice for me and put the dot on, then we could see what happens quickly. Let's do that. Go a little bit faster. And you begin to see something similar to the structure I had. The outcome of this, I genuinely think, is slightly surprising, but also a little tiny bit frightening. This is called the Sierpinski gasket. It turns up all over the place. And it's a fractal thing. But the fact this is genuinely coming from rolling a dice on a computer and doing it quickly makes me, I don't know, just slightly disturbed about reality. Well, we had 3 points. I mean, we could have had 4, we could have 5, we could pick a number. Well, probably a whole number, otherwise counting the points is difficult. But we could have 4 points and say, well, let's roll a dice or a 4-sided dice, a D4, to go to one of those. What pattern would you get? You could say, instead of going halfway, go a third of the way or 3/4 of the way. What will happen? Do any of them make patterns? Do they go chaotic? If you look up this particular rule, you get this picture. After a while, you start to see these green dots appearing in what looks like a very structured way. In fact, it becomes very obvious if you run it long enough that the picture you're getting looks like something real, looks like a fern. Accurate. This is a nice example of how you don't have to draw something natural by hand. All the information for this fern is captured in a few lines of probability, like the rules of the game are the fern, or are a picture of a fern. It's actually really useful if you want to program video game graphics. You don't want to draw every tree, every fern. So if you can just kind of store all the trees and ferns as a rule and say whenever you want a fern, you just do that for a while. That is a much easier way to sort of, and lots of natural things turn out to have this fractal structure, that self-similar things, which means you can generate them by iterating stuff.